All right. Hi guys, today we're going to be doing a simple conversion from, or we're going to be working on quadratic functions, but we're going to go from standard form all the way to vertex form. And I'm going to show you guys how it's done because there's a couple methods you can go, you can do to get your answer. So what is a quadratic equation? So if I write over here f of x, I'm sure you guys have seen it before, but it'd be like f of x equals, let's say 4x squared plus 8x plus 5. This would be a quadratic equation. You can also have f of x would equal 4x minus 2 squared plus 8. That's also a quadratic equation. All right. Now, I'm sure you guys know this, but we're going to go over it again. So standard form, right? What is standard form? Standard form has the skeleton that looks like this. Y equals a of x squared plus b of x plus c. Okay. Then you have your vertex form, which would look something like y equals a x minus h squared plus k. Okay. Where your vertex in this one, in both cases, by the way, well, actually, hold on. Vertex here would equal h and k. And in both cases, a cannot equal 0. Okay. So those are your two general forms you're going to use. And I'm going to tell you today how to convert from standard form to vertex form. Okay. So let's start off with completing the squares. By the way, this whole document that I'm going to make right here will be available down in the description. So you guys could, completing the squares. So you guys could go over it, and if you want to download it or whatever, it's up to you. Anyway, so completing the squares. Let's say we're given this quadratic equation here. Y equals, actually, you know what? Let's go f of x, which is the same as saying y, by the way. So f of x equals x squared plus 6x plus 5. All right, what form is this, by the way? This form is standard form, so we now want to go to vertex form. So completing the squares, how do we do this? This is the way I like to do it. All right, you can do it a different way too, but this is how we're going to do it. So let's continue here. So we're going to go here, right? We're going to group the x's together. So we're going to have x squared plus 6x plus 5, right? Now, we normally want to take this value here that's underlined in red. You want to take half of it. So you want to do half, right? And then you want to square it. So you times it by a half and then you square it. Okay? So in this case here, you would have something like x squared. So what's a half of 6? 3. 3 squared is 9. So plus 6x plus 9, right? Then, yeah, so hold on. Yeah. Then plus 5. And since we added a 9, we have to subtract the 9. Because if we were to add these two together, it would still come out to this one up here. Okay? So I'm going to get rid of that. So now what we could do is, okay, this is one way. I'm gonna show you two ways here, but what I was taught is you do whatever number is in front here. Actually, I'm doing it in red. Whatever number is in front here, right? So which is 1, right? Times this number. So something times something would equal the product, or the product of the two underlines here. So in this case, it's 1 times 9, which would equal 9. And then something plus something would equal the middle value. Okay? I'm just going to, oh my God, that was too big. Let's change that up a bit. There you go. Okay? So let's go back here. All right, so something times something would equal the middle, something plus something would equal the middle value. So this is fairly simple. We can do 3, right? Now, if you just do this, 3 times 3 would equal 9, 3 plus 3 would equal 6. And then, which just gives us x plus 3 squared, right? plus 5 minus 9, of course. But this here still is the same as saying the one above. Now, there's a different way you can go about this, which I will do on the side here. So instead of doing the whole process of, of timesing it by half and squaring it all in one go, you could do it like this. So you could do x squared, right, plus 6x plus 3, right, because a half of 6 is 3, 3 squared, plus 5 minus 3 squared. Okay. Now in this case, this is just a different way of doing it. What's going to be inside the brackets would be x, of course. You take this sign here, so in this case it's plus, and you take this number here before squaring it, which would also equal 3, right? And then you add the square outside like that. That's also another way you can get to the same answer here. This is just a workaround. I mean, you can see clearly the numbers. This will always work. This too would also always work. It's the method you prefer. So then plus 5 minus 9. And so we'll continue down here from this one. So in this case here, we have x plus 3 squared. So 5 minus 9 would equal minus 4. And now we have our vertex form. So f of x would equal this. Now, what is our h and k? So, and also, what is our a, right? Our a in this case would equal 1. Our h would equal, now remember, if we go back to, where is it? Right here. The formula is y equals a x minus h squared plus k. So it's minus h. So in this case down here, h would equal minus 3. So you put minus 3 into minus h, you get positive 3. And then your k is minus 4. So that essentially is all the values you need. This would be your vertex. So vertex, I'll write it out more clearly, equals minus 3 minus 4. And that is your vertex. All right, so that's one way to do it, completing the squares. I showed you both methods to go about it over here. And now I'm going to show you the another way you can do it. Now, so completing the squares, we're going to go over here, and I'm just going to say taking the h value. I'm going to call this taking the h value. Taking the h value. I don't know if this is the actual method, like what's the name of the actual method, but this is just a way you can go about it. So taking the h value, which will be another method. Okay. So now let's take our same question over here, right? F of x equals x squared plus 6x plus 5. Let's copy that and let's bring it over here. All right. So now from here, instead of doing completing the squares, which you guys had seen, we're going to use this formula up here, which is going to be the standard form. So y equals ax squared plus bx plus c. So let's write that down here, just so we don't have to keep going back. So ax squared plus bx plus c. What is our a? What is our b? What is our c? Our a in this case is 1. Our b in this case is 6. Our c in this case is 5. All right. Now, this always works. Instead of doing completing the squares, h would always equal minus b over 2a. Okay. So in this case, what do we got? What is this, by the way, works for the vertex. This will find you your h of the vertex. So in this case, h would equal minus 6 over 2 times 1, which is 2, which would equal 3, minus 3, sorry. So minus 3. Now we can plug in this minus 3, which is h, which is also the same as saying x, right? If you know your vertex, h is x and k is y. So now we can plug this value back into this. Back into there, all right? So what we're going to do now is we're going to take our minus 3 and we're going to plug it in. So f of minus 3 would equal minus 3 squared plus 6 times minus 3 plus 5. And this will give us our k value at the h. All right, so just give us our k value. So f of minus 3, if I put this all into a calculator, I'm going to do it all in one shot. So what is this? 9. This is 9 plus, so 9 minus 18 plus 5, which equals minus 4. So f of 3 minus 3 equals minus 4. So now we have our h and k. H and k, which is our vertex, would also equal minus 3 minus 4. All right. But we're not done, right? The form we want is the f of x, or sorry, let's do y this time. Y equals ax minus h squared plus k. So we can plug in our h and k since we have those values. So a x minus 3, plus 3, because minus with minus is positive, minus 4. Okay. Now, what is our a? We already have our a. Our a is this here, which is 1, right? Because we use the standard form up here. So now we go back down here. So now we could just say y equals x plus 3 squared minus 4. We don't have to put the 1, and that is our final answer. And if we go over here, it's the same answer. So there's two ways you can go about this. I don't know if this is the actual name, taking the h value, but this is a proper method. Like, you can use this method to actually get your vertex form from our standard form. All right, so you could choose either or. Personally, I find the one on the right much easier than the one on the left. But again, it's up to you. I will also have this sheet down in the description if you want to download it. And hopefully this helped.